Okay, now I'm going to talk about the Wolverine SMP. Wolverine SMP stands for single moving part, based on the fact that it only has really one moving part, which would be the solenoid or single solenoid, but actually there's two. There's the nozzle moves and the solenoid actually triggers. So I guess the single moving part is the nozzle, but it's a much smaller engine than the one I showed previously, the Polar Star Fusion engine, because its primary design is to be a drop-in into an existing gearbox. So you'll take the gearbox from an existing gun, replace the cylinder with this engine, and reinstall it. So there's quite a few advantages by doing that. I'll cover all the advantages and disadvantages, in my opinion, on the Wolverine SMP. It's a simple design. It has far fewer parts. You notice it's very small. Not much to this, but a front cylinder which contains the nozzle, and then it has the rear part which contains the main solenoid. It's a direct fire through the solenoid, so the air that goes out the nozzle travels through this larger solenoid back here. But again, it's very simple. If you take this thing apart, you actually only have a couple screws and it's disassembled. You have the front banjo valve here that controls the nozzle staying back, and then you have a couple of set screws on the side, and the outer cylinder comes off and the nozzle comes out, and then you just have the rear part here. And actually, when you unscrew this, which is the main solenoid, that's it. 4 parts essentially that make up the engine. So an advantage of this, it's far fewer parts. It makes it very simple to clean and maintain that way. It's potentially more air efficient. Now, I haven't verified this myself, but there's a lot of empirical evidence from other folks who have fielded the SMP a lot longer that they're getting quite a few more shots per tank. I think that's certainly true with the lower velocity, since this will operate in its operating PSI range goes as low as 40 PSI all the way up to 120 PSI. So certainly at 40 PSI you're going to get a lot more efficient air usage, since there is only one solenoid. You don't have extra air going to the other solenoids. It's naturally limited by the internal workings of the solenoid of how much air actually flows through per shot. So it could be very efficient. Some are reporting twice as efficient. Again, this is my opinion piece here. I haven't tried it yet. I believe it will be more efficient, but I haven't had a chance to go out and empirically demonstrate this for myself. So that is an advantage for this. Because it's a cylinder-based replacement, another advantage is it's designed to fit in basically any gun that uses a standard cylinder with a centered nozzle. So it doesn't have to be just a V2. In fact, the same engine works in a V3 or and many different guns that don't use standard V2 gearboxes. For example, the 417 or the XCR, or some of the other guns where they've made some tweaks to the way their engines are put together. This will fit, for the most part, in the cylinder portion of those gearboxes. So it's very flexible in its installation capabilities. You can wire this forward or rearward based on the gearbox shell that you install it in. So since it doesn't have a gearbox, the wiring harness that comes with it can be wired in whatever direction makes sense for what the gearbox allows, and I'll talk about that a little bit more as well. It is a rear bias nozzle. Let me describe what that means. Having a rear bias nozzle means when this engine is at rest, I'm just going to reassemble it here while I'm talking. While this engine is at rest, the nozzle stays retracted fully back into the engine. When it fires, the nozzle goes forward, shoots out the air, and then retracts again, which chambers another round. So this rear bias is an advantage, and it can also be a disadvantage. It's an advantage for some guns, especially the scissor guns, like the SCAR gun or the G36 guns, where the lower pulls away from the upper. Because the nozzle is always completely back, the nozzle isn't embedded in the hop-up, so it doesn't lock itself in place. So that's an advantage. It's rear bias. I'm going to talk about some of the potential problems by having it rear bias as well when I get to the disadvantages, but for some guns that works out very nicely. It's very simple to adjust. I mean, that's part of the claim of this engine. It's simple. There's only two settings you can control using its FCU circuit. Just the nozzle dwell and the rate of fire. The rate of fire is just the delay between shots. The nozzle dwell essentially controls how long this solenoid is energized, which determines how much air needs to get pushed through here to make it function. So you're going to end up adjusting the nozzle dwell to match your input PSI. Generally at a lower PSI you might need to have slightly higher nozzle dwell to compensate and allow the nozzle to move fully forward and shoot the air out. So it's very simple. The FCU itself is actually much smaller than a Polar Star FCU. I can just show you one here, which is a test FCU. You can see the size difference. It's a lot smaller, which helps it fit inside buffer tubes much easier. This fits in there very easily without any binding. So the small FCU is definitely an advantage. Let's see. It doesn't drain the battery as well because there's no display on this FCU, and I'll talk about how you adjust this in a second. Because this FCU doesn't have a display, you can leave the battery plugged into this almost indefinitely. As long as it's not being used, it's not drawing any power, and you don't have to worry about killing your LiPo battery if you leave it attached overnight like you would get with a Polar Star FCU. Again, I personally always remove the battery even if it doesn't drain it, but it's just good to know if you forget, and everyone's done it at least once, you forget to unplug the battery, it'll still be good. What's also nice is the Wolverine SMP comes with a 500 milliamp hour battery with the engine, so that's also a plus. You already have it ready to go. You've got a battery. The battery will fit inside a buffer tube very easily along with the FCU. Very nice. Okay, let me go over some of the potential disadvantages of the Wolverine SMP. Like the Polar Star engine, it uses a wire harness to connect the fire control unit to the SMP engine. And same problem here, these wire harnesses can be pretty fragile. This uses a different connector system than the Polar Star engine, but at the same time you still have the problem that something can wear out, break. You got to be careful with your wiring harnesses. So this can be seen as a liability as well. In my opinion, the installation of an SMP is actually more complex than, say, the Polar Star engine. Because what you have to do to install it is you have to take out the existing gearbox, open it up, and in this case there's 10 screws or so that you have to open up to get the gearbox apart. You then have to take out all the gears, clean out all the grease, which is kind of a pain, and then you can install the engine. Now once you've got it all taken apart and cleaned out, the installation is actually pretty straightforward. You replace the cylinder. It comes with a trigger board that replaces the trigger mechanism, and just install that and you're good to go. Just install the trigger and so forth. But again, it's honestly more of a pain. You got to clean out the grease. It's not good to leave all that extra gunk that's inside here. Also, anytime you need to get access to the engine to lubricate the nozzle, it requires you to open up the gearbox shell. So there's a little bit of extra work. Frankly, you got to take the whole gearbox out of the gun. You got to unscrew all the gears, unscrew all the screws that hold the gearbox shell in place, and you have the trigger, which is on its own spring, sometimes pops out. So you got to play. Those who are familiar with working with AEG gearboxes, you got to play the little hold all the parts in place while you reassemble it. Now it's certainly much easier without the larger spring, but once it's all together, it's probably not that difficult. But it's not just pull out a gearbox and drop one in. It uses the existing gearbox. Now again, that's an advantage in that you don't often have alignment or shimming issues because you're using the gearbox that's native to the gun that you're replacing, as long as you stick with the same gearbox. If it was working as an AEG, it should work fine as an SMP because everything is designed as one part. Gearbox belongs with the gun. Now there are some disadvantages again to that too. Not all gearbox shells are made the same. Unfortunately, because it works as a cylinder, different thicknesses in the front of the gearbox or different reinforcements within the gearbox can cause problems for how all of this fits inside of here. So you have to be aware that while the gearbox shell itself is designed for the gun, the gearbox shell has variations that may cause problems for the installation of the SMP. So just keep that in mind. Not all gearbox shells are created equal. Additionally, a lot of gearboxes on some guns have different trigger mechanisms. They aren't using a standard V2 trigger setup. They'll use a micro switch, or they'll use some other mechanism. So as soon as you go away from anything that follows the standard V2 trigger, you're now forced to do something to wire the trigger switch directly to the wire harness, or you can use a circuit board like I've developed for helping the install of these things. So again, advantages and disadvantages you have to be aware of. If you got a really odd gearbox, Aries in particular, you still have to do some custom work to get this installed. And the maintenance of it, I think, is actually a little bit more difficult because you have to take apart the gearbox to get at the nozzle. There are other modifications that are being developed that allow you to not have to do that, but that requires like cutting the gearbox shell. And I don't think the average user is going to want to be able to do that or be able to do that. So keep that in mind. Let's see, some of the other interesting things. The current, or the iteration I'm showing here, uses barbed fittings for the Airline. Now it's designed this way to be more compatible with the different gearbox shells because there's very limited room for this Airline to pass, so it has barbed fittings here. Unfortunately, with a barbed fitting, if you ever need to replace this Airline, it's extremely difficult to get it off this barbed fitting. In fact, you have to cut it off. You can't pull this thing off of there. So maintaining this Airline is very difficult. Now I know Wolverine has made an improvement to their fitting here, where I don't believe they're using an elbow anymore. It's a softer Airline that has like a mesh wrap like this around it, and it I think it's still attached by a barbed fitting up here, but it allows you to be more flexible, so you can actually, because this is already pointing downward, meant it's supposed to go out the grip, you can do the milsim type of thing by having to go out the back of the gearbox without removing this elbow. Another point about that milsim fitting, if you want the Airline to go out the back, most gearbox shells aren't designed for that, so you're forced to actually have to make a modification and make a cut. So again, be aware of that. A lot of gearboxes aren't designed to handle even this large wire harness out the back of the engine. So even on this generic shell that I have here, in order for the wire harness to go out the back, it gets pinched right back here on the gearbox shell. So it would be appropriate to cut away some of the metal here to allow this wire harness to go more easily out the back, or you sort of have to snake it in the same pathway as the motor wires, and they were much smaller, so you just have to be aware of those kinds of issues when you do the install on this. Okay, let's see. I think I mentioned earlier about the rear bias nozzle. The rear bias nozzle, which is a function of the simplicity of the engine, it doesn't have a poppet and a nozzle solenoid. It has one solenoid, which just is used to control the air. The nozzle is always sitting back. So what that means is when this is in a hop-up, there's always BBs sitting in front of this nozzle, and there's technically nothing but the bucking that prevents BBs from going into the hop-up. So if your bucking is poor, sometimes the feed pressure from your magazine can push multiple BBs into the hop-up, and what that means is you need to probably change your bucking to something with a smaller opening on it to help prevent BBs from feeding into the hop-up. The other unfortunate thing with a rear bias nozzle is it's very difficult to check for air seal because it's always sitting on the back. You can kind of manually push it forward and then fit your hop up against it, but any bumping of that can actually push it out of place. So because it's all the way back, air seal is a little bit harder to test, and that's unfortunate, but usually the nozzle will be okay with the hop up that you're working with. If you get it for what it's designed for, like a V2 will work with an M4 based gun. Back to the FCU. I mentioned it's very nice and small. and very fits in the buffer tube. But unfortunately, the way you adjust the FCU is through these little analog control dials on here. There's one for the DN and one for the rate of fire. And Wolverine conveniently includes a tool for you to be able to adjust the little dial settings on here. And that's nice. Again, it's very small. If you get it set the way you need to, then you don't have to mess with it. But adjusting this is actually very difficult to get very precise adjustments, because it's hard to know exactly what any amount of turn on the analog dial actually relates to, as in what effect it has on the engine, other than it either increases or decreases it. But again, you're dealing with an analog control here. You need to use a little tiny screwdriver, and you have to be very precise on your adjustments if you want to get it right to the edge of performance. You can obviously make very gross adjustments and just leave it and be good. One of the things though with the rate of fire, as you adjust this dial for the rate of fire, there's really no way to know what your rate of fire is without going to a chrono and actually firing babies through it so it counts it. Or there's other techniques, but you can't tell. You just sort of have to guess that you're at the right rate of fire. So I kind of consider that a disadvantage, in that you, one, have to have a tool handy, and two, it's very imprecise on how you adjust this. The way you adjust the rate, the burst mode on this, is by using the trigger. So there's a little LED light that lights up on here, and you plug in the battery while holding the trigger, and then you can actually determine your burst modes using various trigger counts. And also, one other issue about the FCU is there is solder ports on here to allow this FCU to control a box mag. It actually, whenever the trigger is pulled, this port goes active, which allows you to turn on a box mag or a flashlight or something else. Unfortunately, it's under the heat shrink, and in order to use it, you actually have to cut the heat shrink off, solder a connector to it, and then probably reapply the heat shrink. On the Polar Star FCU, for example, they have an extra port mounted right on the board where you can plug in a connector for that same functionality. They call it the GPIO port, or general purpose IO. On here, I believe it's called the mag button or something like that. But not every gun uses that. But if you want to put this into a saw and you want to hook it up with a box mag, you're going to have to solder things directly to the FCU. Also, there isn't a mode for switching semi and full auto. So again, if you're putting this into a gun that's always full auto, like a saw, you actually have to force the full auto switch to be closed. And you can do that through a variety of ways. You wouldn't be using this trigger board anyway, but that's just things to be aware of. And it's intended native design to work in just V2s, so you don't have to worry about a lot of those problems. But I'm just pointing out, as you start putting these into different platforms, because it's designed to work as a cylinder replacement for different platforms, you may have to overcome some of these things, like wiring up the trigger or wiring up the full auto, if it doesn't use a standard V2. So be aware of that when you're doing various custom or various installs of this, and it's not, again, the standard platform for it. Let's see, the design of the engine also has a natural limit on its max FPS. Because the air is traveling through this solenoid, I don't believe you can get up to 700 FPS with the SMP. Now, not many people want to get that hot anyway, so that's perfectly fine. But it has a natural limit. You go up to 120 psi. There are no different nozzle diameters. Your FPS is controlled entirely by your input psi. So your FPS is what it is based on your psi. You shoot it at 80 psi, at 40 psi, whatever the FPS, that's what you're going to get with your barrel and hop up combination. When you get up to the top end of this at the 120 psi, that's your max FPS. Unless you start creeping up on your input psi, you're not going to be able to get any higher than that. And again, it's naturally limited by the air going through this main solenoid. Now, the max FPS on this is somewhere up to I think it's around 500 FPS. Again, it depends on your barrel, because the barrel length has and diameter has a big effect on that. But again, that'll cover the majority of all guns and FPS ranges that people need to use. So it shouldn't necessarily be a problem, but you should be aware that if you want to be a sniper shooting 650 FPS, the SMP may not be what you're going to need because the flow just won't support that. All right, I think that's about it. I just wanted to point out again, it could be much more efficient. I mean, it's real big point here is this could be a lot more efficient. So those who don't have easy access to air, you could probably use an SMP on a tank and get quite a few more shots than what you would get with some of the other engines. So be aware of that. So it's a cool little thing. This actually, you know, I do a lot of custom installs for using the Polar Star into various guns, and it in some guns takes pretty extreme modifications to install it, like the 417 or a PSG or something like that. This installs much easier into those because it doesn't require any cutting of the gearbox shell. The existing shell can work. You can install this. So actually for things like the PTS Masada, the 417, the PSG, I actually recommend the Wolverine is a better drop-in. It's much easier to put in there. You just get the right length nozzle and you're good to go. So just be aware of some of the advantages and disadvantages. It's also the least expensive engine out on the market. Of the three that I'm reviewing, this costs the least amount. So, and it comes with a battery, which is really cool. So be aware of that also. Okay, next up I'm going to talk about the Vulcan V12.